Hello everyone. In this occasion, I would like to present our paper. The title is A Generalization of Transmission Power Optimization Method for Concurrently Communicating Multiple Access Points in Wireless Local Area Network. My name is Hendy Berantoro from Okayama University. Here's the outline of my presentation. I will start from the background and contribution. Today, WLAN is widely used around the world because it offers flexible internet access with low-cost installation of access points. In access point, if we set the high transmission power, it will cause high capacity as well as high coverage area. However, its interference will be also high. In the other hand, if we set low power of AP, it will cause both the capacity and coverage area low, but the interference will be also low. In multiple APs, we should optimize transmission power in order to maximize WLAN performance. In wireless communication, there's a metric to measure communication quality. It's called SNR, or signal to noise ratio. SNR is comparing received signal and noise. Previously, we proposed a transmission power optimization method for concurrently communicating to APs. In this method, we maximize the total throughput by optimizing the power. The method only selects the combination between maximum and minimum power because this combination shows the best performance. In previous study, AP1 and AP2 are associated with multiple hosts. For example, AP1 is connected with host 11 and host 12, while AP2 is connected with host 21 and host 22. We assign for power combination. The first combination, we set both APs in minimum power. You can take a look at this color. I give the red color for maximum power and blue for minimum power. And the second combination is when AP1 is set into minimum power and AP2 in maximum power. And the third combination, AP1 is maximum power and AP2 is minimum power. And the last combination, both APs are in maximum power. At each combination, we measure the RSS at the AP from the associated host and interference signal from neighbor APs and neighbor hosts. Then we calculate the SNR. After that, we select the power combination that gives the highest SNR. Here I will show the procedure of the previous method. First, we set power of both APs in minimum power. And next, we measure RSS at AP1 from its associated host and also the RSS from AP2 and its host. And then we need to measure RSS at AP2 from the its associated host and from AP1 and its host. The next step is calculating SNR at the AP using this following formula. This is the RSS from associated host, and then this one, the RSS from AP2 and its host. And in this formula, we consider about the outside AP. And then we also measure SNR at AP2 using this formula. After that, we calculate average SNR. Now we go to the second combination. Here we set the AP1 to minimum and AP2 to maximum. And the next procedure is the same as the done at the combination 1. We measure the RSS and calculate the SNR. At the combination 3 is by setting AP1 into maximum and AP2 in minimum. The procedure is the same as the previous, that is the measuring RSS and calculate the SNR. And the last combination is set AP1 and AP2 into maximum power, then again doing the same procedure, that is measuring RSS and calculate the SNR. After all combinations are complete, we choose the power combination that has the largest SNR. Then assign the corresponding powers to the APs. However, this one is drawback of previous method. The previous method is only limited to 2 APs. If the number of APs is n, it needs 2 power n SNR measurements, which is not affordable for a large n. So in this paper, we generalize the transmission power optimization method for handling any number of APs in dense WLAN, and then reduce the number of SNR measurement to at most the number of APs. Next, I will introduce the generalization of AP transmission power optimization method. The key in this method is the reduction of SNR measurement. Basically, if there is no interference, maximum power of AP gives the highest throughput. However, if there is interference, power of some AP should be minimized. When the distance between the AP and the host is short, even the minimum power of the AP does not decrease the total throughput due to the nonlinear feature of the throughput performance. Then power of AP should be changed to minimum if the associated host is close from it. And then we change power of AP sequentially in descending order of RSS. Here's the optimization procedure of this method. First, we assign maximum power for all APs. And then we measure RSS from the AP1 and then from the AP2, then from the AP3. For that, we calculate the SNR by using this formula. And then we also calculate the average SNR from the all SNR of the APs. Then we sort the APs in descending order of RSS and make the short list of the APs. Then we select the first AP in the list and assign the minimum power to the AP. And then we measure again RSS and calculate the SNR. And then we check if the current SNR is smaller than previous one. So we select the previous combination and then stop the procedure. So in this case, the best power for all AP is maximum power. Then if the current SNR is bigger than previous one, we remove the selected AP. It means AP2 and select the first list of AP, it means AP1, and assign minimum power to this AP. And then we measure again the RSS and calculate SNR. And then we check if the current SNR is smaller than previous one. Then we select the previous power combination and stop. In this case, the base power for AP1 and AP3 is maximum power, while AP2 is minimum power. Then if the current SNR is bigger, so we remove the selected AP, it means AP1, and assign the minimum power for AP3. Then again, we measure RSS and calculate the SNR. Then check again. If the current SNR is smaller than previous one, then we select the previous power combination. Then for this condition, the base power is minimum for AP1 and AP2 and maximum for AP3. Then if the current SNR is bigger, so we stop the procedure and the base power for all AP is minimum power. Then I will introduce the evaluation for this method. This setup for the evaluation. In this evaluation, we use PC laptop for servers and hosts, and then we use Raspberry Pi 3B Plus and TP-Link wireless and edge adapter for AP by running host APD. And then we use iPub software to measure the throughput by generating TCP traffic for 60 seconds. And then we use this window size and buffer size. And then the RSS is measured using IW commands. In this evaluation, we use the third floor of engineering building number 2 in Okayama University. This is the first topology for this evaluation. In this topology, AP and host in close distance. Here's the result for this topology. In this table, it shows the average SNR obtaining by measuring RSS and then show the total throughput. From this result, the method can select the base power for all APs. In this topology, the base power is minimum power for all APs because any host is closely located from associated AP. Then, for second topology, we move the host 1 to next room. Then this is a result for this topology. The method can select the base power for all APs. The base power for AP1 become maximum because host 1 is in different room. The maximum power can avoid the throughput drop by the signal attenuation at the wall. And then this third topology, again, the method can select the base power for all APs. In this case, the base power for AP1 and AP3 is minimum, while AP2 is maximum. And then for fourth topology, the base power for AP1 and AP3 is maximum because host 1 is far from AP1 and host 3 is far from AP3. And this one is fifth topology. The base power for this topology is minimum power for AP1 and maximum power for AP2 and AP3. And here's the sixth topology. The base power for all AP is maximum because all hosts are far from associated APs. Then this one is 7 topology. In this topology, the method cannot select the best power for all APs because all hosts and all APs are in the same room. And this topology also, this method cannot select the best power for all APs because two APs and two hosts are in the same room. So it is necessary to optimize both channel assignment and power together, which will be in future studies. Then we also evaluate using two hosts is associated with one AP. In this topology, the best power is minimum power for all APs because any host is closely located from the associated AP. And for second topology, again, the method can select the best power for all APs. The best power for AP1 become maximum because one host is in different room and the signal is alternated by the concrete wall. And third topology, again, the method can select the best power for all APs. And then for topology, the best power for this topology is minimum for AP1 and maximum for AP2 and AP3. And then for fifth topology, the best power for all AP is maximum because some hosts are far and placed at different room from the associated APs. Next, I will show the evaluation for 4 AP case. In the first topology, AP and host is in close distance. In this topology, the method can select the best power for all APs. The best power is minimum for all APs because any host is closely located from the associated AP. Then, for second topology, again, the method can select the best power for all APs. In this topology, the best power for AP1 become maximum because host 1 is in different room. And the third topology, the best power is maximum for AP1 and AP2 because host 1 in different room and host 2 is in far from the AP2. The fourth topology, again, the method can select the best power for all APs. In this case, the maximum power should be assigned at the AP1, AP2, and AP3 and minimum for AP4. And then we also evaluate with two hosts associated with one host. Again, the method can select the best power for all APs. Then for the sixth topology, the best power for this topology is maximum because one associated host is located in different room or far from AP. The conclusion, we propose the generalization of transmission power optimization method for handling any number of APs in dense WLAN. And the proposed method can select the best transmission power for the APs except for the cases where multiple APs are located in small room. In the future, we improve the proposed method by jointly optimizing the transmission power and the channel assignment for the APs. Thank you very much.